Well, thank you very much indeed. And I'd love to thank the President and Michael and everybody else for this wonderful achievement. I mean, it's a real honor and a privilege. And I just want to say a couple of things to start with. One of them is that the reason I self-nominated, I've never done that before. And the reason I did it was because I wasn't, strictly speaking, an Imperial alumni. I was a student at Westminster Hospital Medical School, which was then absorbed into Charing Cross, which has then become merged with Imperial, St. Mary's, etc., and the Hammersmith. So I was very pleased to be given this award because I feel that a Westminster woman is something quite unusual. There are only about 7 of us each year, and I think that I was, not saying that by any means I was the most suitable person to be honoured, but I just wanted to make sure somebody from Westminster had a chance. Okay, so now you've heard very nicely, and thank you for that, the sort of things that I do. I try to find antibodies that we believe are causing disease in patients with neurological symptoms, and then knowing that if I find a useful antibody, the patients can be treated, because there are a number of what we call immunotherapies, treatments, that reduce antibody levels in the patient, and the patient will get better. So that's very simply what I've done for about the last 50 years. And I was asked specifically to talk about what motivated me in research and what inspired me. So I'm going to do that more or less strictly. I have some notes. I suspect that I will deviate quite seriously from them. I hope I won't ramble on too much, but I've got to that age where you do tend to ramble on a bit. Anyway, I would like to say of what motivated me. I think that's quite important. So basically, I was a scientist from the beginning, I think. I liked nature. I liked drawing things. I didn't play with dolls very much. And I read a lot about science. And in those days, reading about science was not popular stuff. It was science textbooks that I got from the library. So I was quite serious about it. And I really was fascinated by the fact that people had done all this science. Not so much that I remembered it all, because I didn't. In fact, I've had a very bad memory. And I think that's probably a good thing, because I always try to work things out for myself rather than remembering what somebody else has said. So those of you who have bad memories, don't worry. Anyway, I wanted to be a scientist. My parents were not so keen. They thought ladies in dirty white coats were not what they wanted to associate with. But when I said, well, okay, I'll do medicine then, that was fine, because that's respectable. So I became a doctor, and I'm very grateful for the years I spent at Westminster, and the year I spent actually at the what's now Westminster and Chelsea Hospital, and also at St. Charles, which I'm not sure if that's actually connected with Imperial any longer, but was connected with St. Mary's at the time. So I did those 1 year of house jobs there, and I really enjoyed it. But I wanted to find out more about the biological basis of disease. And I did a MSc, a master's in biochemistry at UCL. And that was transformative, because it really showed me that one can learn about all these wonderful things that control the cells, genes, enzymes, pathways in the cells. And there was so much to know, and I thought I'd just continue to be a basic scientist. After a rather abortive project, which I did in the biochemistry department at UCL, I then summoned up the courage to go upstairs and ask if I could work with somebody called Riccardo Milady. And Riccardo worked in the department very closely with the head of department, who was Professor Sir Bernard Katz, Nobel laureate. So this was a very distinguished department. It was probably the most famous biophysics department in the world. And Riccardo, being the nice sort of person he was, said, oh yeah, you can come and work with me. And so I did. And those 5 years with him, those were what was really again, transformative for me because it was a wonderful atmosphere, very clever people, another Nobel Prize winner among the people I had coffee with every morning. And it was taught one that you could do science with humor, tolerance, imagination, and great friendship. And what could be nicer than spending your time working in that sort of environment? So I really enjoyed it, and I thought I would stick to basic science. But as things happened, Ricardo, who had obviously been thinking about this before, said he wanted to work on this disease called myasthenia gravis. He contacted somebody called John Newsom Davis, who was working at Queen Square as a neurologist, and together with myself, we developed a little program on myasthenia, this disease of the nervous system, which makes you very weak. And it was about that time that others in America were able to show that there were antibodies in these patients that interfered with the way that the nerves activate muscles. So if you had one of these antibodies in your blood, it went to the muscle and stopped your nerves being able to tell your muscle to contract. So the patients get very weak and floppy. Anyway, I started helping John and Ricardo work on myasthenia. And John did something remarkable, which actually was to do with Imperial. So I thought I ought to mention this, because the first time that anybody was treated very convincingly for this disease was at Imperial, at the Hammersmith, in fact, where they did the first plasma exchange on a patient with myasthenia. So plasma exchange, you're removing the antibodies and putting in a substitute antibody, which is a healthy antibody, as it were. And when you do this with a patient with myasthenia, the patient literally, almost literally, gets up and walks within a few days. So somebody who might have been bedridden in intensive care was transformed by this treatment. It's a temporary treatment, the antibodies come back, and you have to do other things. But that actual experiment, really, of treatment was very, very impressive, and actually that was done at the Hammersmith with Keith Peters and his colleagues. So this was all going on in the field of myasthenia. John Newsom Davis asked me to go and work with him and to help him set up a group, and that's what we did. And in fact, we recruited subsequently 2 Imperial alumni who were both PhD students of Professor Eric Barnard, who was the professor of biochemistry here at that time. So again, a connection. Eventually, after about 10 years, we went off to Oxford, where John was made professor of neurology, and we set up the lab there, and things went very well. And that's where I set up the clinical service to diagnose patients with myasthenia gravis, but also with a number of other diseases in which we were beginning to find specific antibodies that were causative for the disease. So after that, things really began to sort of blossom. John Newsom Davis had to retire, unfortunately, though he did many other very important things subsequently. And he let me take over the group, which was exciting. And because I'd taken over, and because I had this medical degree in the background, despite the fact it was then about 30 years since I'd touched a patient, and it's now 50 years since I last touched a patient, that medical background had made a tremendous difference, because I could talk to the doctors. And the doctors emailed me and said, I don't know what's going on in this patient, and they'd explain to me what the patient's symptoms were. And every now and then, and very occasionally, really, we would say, we think this is an antibody to such and such a protein. Let's try and see if we can find that antibody in this patient's blood to explain their disease. And that's really all that I've become famous for, or so-called famous. It's really very simple, but when it works, it's terribly exciting, because you know that there are going to be other patients who have the same antibody, and you can help the doctors diagnose those patients in order to treat them properly with immunotherapies. So I think I could say that my motivations have been and it's sort of instinctive love of science, working with people who are fantastic, and of course they have been fantastic, otherwise the work wouldn't have been done. I think the doctors who I've been able to communicate with have been a great, trying to think of the right word. It's a great aspect of doing this sort of work, to be able to communicate between the lab and the clinic. And of course, the inspiration has actually been the patients. Not so many of them, but just that handful of patients where we have managed to make a discovery that has really helped them and others subsequently. So now I'm in that position where I'm not, I don't have a lab. I'm trying to help a few young people around the place to get on and do better, and help them with their careers. And actually, I think ultimately, when you get to my age, what you're really excited about is the young people. And the nice thing about young people and about science is that virtually everybody's young, because you know what it's like. There's this bottleneck at the bottom, lots and lots of people doing the science, not that many people at the top. So it's actually very rejuvenating to work with scientists. And I'm really delighted to be part of this Imperial College Alumni event because of the young people here today, and the not quite so young, but very distinguished second speaker. And I mean, to be honest, I think I need to feel needed. And so when I go to talk to people and to try and help them with their careers, they're doing me a great favor. Thank you very much.